Was Mars ever habitable? To answer that, let's start by examining the ancient water features on the planet. As we traverse the Martian landscape, we notice distinct geological features that hint at the presence of liquid water in Mars' past. Just imagine river valleys etched into the Martian soil, lake basins nestled between towering peaks, and ancient deltas whispering tales of water once flowing freely. Each of these features tells a story of a time when Mars may have been a wet world, much like our own Earth. These water remnants are not mere geological curiosities. They are crucial indicators of the potential habitability of Mars. They suggest that there was once enough water, and thus the necessary conditions, to possibly support life. So as we ponder the question of Mars' habitability, we find ourselves looking back in time to a Mars that was once a wet world, potentially capable of supporting life. Moving forward in time, let's explore the evidence of lake beds and sedimentary deposits on Mars. Observations from orbiters and rovers like the ever-curious Curiosity point to Mars' once aqueous existence. These scientific sleuths have identified geological features that suggest standing bodies of water once graced the Martian surface. Imagine, if you will, Martian lakes, serene and potentially teeming with life. But the Martian mysteries don't stop there. Recent discoveries have unveiled a world beneath the world, with subsurface ice hidden beneath Mars' red facade. And then there's the briny water flows. Yes, you heard that right. Salty water has been detected flowing across the planet's surface during certain seasons. This intriguing evidence alludes to the potential for life, perhaps not as we know it, but life nonetheless. These discoveries not only tell us about Mars's watery past, but also hint at the possibility of life beneath its surface. So, what about Mars's early atmosphere, and what does mineral evidence suggest about its habitability? Well, let's dive in. It's hypothesized that in its early days, Mars was swaddled in a much thicker atmosphere. This dense atmospheric blanket could have nurtured a more temperate climate, and, more importantly, sustained liquid water on the planet's surface, a key ingredient for life as we know it. But what about the minerals, you ask? Mars has been quite generous in this respect. Certain minerals associated with water, like clays and sulfates, have been identified on Mars. These minerals often form in the presence of liquid water, suggesting that at some point Mars may have been a rather wet place. They provide a fascinating glimpse into the conditions that existed on the red planet billions of years ago. The clues from Mars's early atmosphere and mineral evidence further reinforce the idea of a once potentially habitable planet. But what about today? What does the current environment on Mars tell us about its habitability? Well, the present-day Mars is a harsh place, much unlike the Earth. Its atmosphere is thin, providing little to no protection from the bombardment of cosmic and solar radiation. This radiation can damage biological molecules, making it difficult for life as we know it to survive on the surface. The thin atmosphere also means that Mars has a cold surface temperature, another hurdle for life. However, it's worth noting that these conditions are not universal. Some regions of Mars, such as the subsurface, might offer more favorable conditions, shielded from the harsh radiation and extreme temperatures. But it's clear that the present-day radiation environment on Mars poses significant challenges for life. Yet, these challenges also motivate us to continue exploring, to keep pushing the boundaries of our understanding. While the current radiation environment on Mars poses challenges, the planet's past tells a different story, one of potential habitability and, perhaps, life.